Okay, good morning. Welcome to
MathyMath number 191.
MathyMath number 191. So this is the problem you picked out of your geometry book. It says, prove that when you extend the sides of a regular octagon that you get a square. This is an interesting problem. You got it? Mm-hmm. Okay. All right, go ahead.
Well, a regular octagon. And we can divide this regular octagon into some shapes. Like this. We know that the interior angle of a regular octagon is 135 degrees.
How do you know that?
Because the sum of the interior angles is 6 times 180, which is 1080. And then divide that by 8, and you get 135.
Okay.
Well, I know that these two lines, I'm going to see if I can prove that we have a bunch of right angles in here. I'm going to prove that these are isosceles right triangles and these are rectangles to maybe help us prove that we have a square on the outside.
All right. Well, why don't you draw the square? Okay.
Well, let's see. These are right angles.
Whoa. How do you know that?
Well, because we have a square.
How do you know that?
Well, actually, no, I don't know that yet.
That's what you're trying to prove.
Well, what I do know is that these lines are parallel.
Okay. How do you know that?
Because we have a regular octagon, and it's symmetrical.
Uh-huh.
So we have the same sort of part of an octagon here.
Okay, well, but that's true for this line and that line as well, and those lines aren't parallel. Like this line is the same part of the octagon as that line is, and they're not parallel. So it's not just that they're the same part of the octagon.
Well, it's that
There's a little bit more to it than that.
They both come off this line segment. And they go down to this, they are both vertical. They're both vertical, and they both have the same, they start out in opposite corners of the same line segment.
Okay, so
that's true.
They're coming from the same part of the octagon. How can you transform this line into this line? What can you do to the octagon? Use a symmetry argument.
Fold it over a line of symmetry right about there.
Okay, that's one way you can do it, and there's actually a second way you can turn that line into the other line.
Well,
It's not folding.
what else could you do? Well, you could flip the octagon. You could just flip the octagon over.
Well, that's sort of similar to folding, but okay, so that's one way, and then there's a third way.
How about rotation?
Yeah, rotating does it too. So there's several different symmetry arguments that show those lines are parallel.
And then that also means that these two lines are parallel. You can use the same argument there.
Okay, yeah.
Well, if these lines are parallel,
Actually, let's make a second movie since we're probably close on time.